Good afternoon, my fabulous chemistry students. This is Mr. Milks with another installment of Unit 1 lecture notes. If you are watching today's video, I think you are on page 17 and we are about to learn how to make accurate measurements. When we are making measurements in the lab, we are going to find that all of our numbers are significant. And when we talk about significant figures, it's starting to help us make sense of uncertainty in the lab. And this arises, of course, because certain measuring devices are going to have more certainty than others. I remember showing you guys the graduated cylinder in class and showing you that it measured plus or minus 1. So it has a built-in uncertainty. And in order to be certain, we have to limit that uncertainty in the lab. And so all of our measured numbers, we will say, are significant. Now here's an example here on the ruler. I see this little arrow is representing right here where our measurement is. Okay, now as I read this thing, of course, it seems pretty elementary that that little line there is definitely greater than 2 and somewhere less than 3. And if we take a step further, the little lines are what we call increments. So here is 2.1, 2.2, 2.3, 4, 5, 6, 7, 8. My measurement is definitely bigger than 2.8 and somewhere less than 2.9. Now, the handy dandy rule for making this estimate, we need to estimate the last number, and I would do it this way. I would see that that measurement, if I were to break this space in half, that where the end of the thing I'm measuring is less than half. So I shouldn't pick 6 or 8. In this case, I'm going to pick 3 because I think it's kind of right in the middle-ish of that half, if you will, of that quarter. So 2.83. All three numbers are significant, and this last number is the one that we estimated to give the most accurate reading we possibly could. So in class and in lab this year, every time you use a ruler, I'm expecting to see your number that you measure to have at least 2 decimal places because I have that ability to estimate that third number. So we got to be careful and take our time and make it as accurate of a reading as we can do. Now in a graduated cylinder, of course, we're going to measure volume. And to do that, we need to measure the meniscus. The meniscus is this bottom piece, right there where that green dot is. We want to be at the very low point of that water. And a graduated cylinder is designed to measure there. What I don't want to do is measure up on the edge, like up here. That's not going to provide me an accurate measurement. Now when I read this, I can see that this big line is 25. I'm definitely above that. I'm above 26. And I am above 27. It looks like I'm right about halfway in between 27 and 28. So my reading would be 27.5. And then my estimated digit would be that 0.5. Okay, so in graduated cylinders, for the most part in lab this year, we should be able to take out to 1 decimal place, unless we're dealing with one of the real small graduated cylinders that has that tenth of a milliliter on it. Okay. So if we're still having trouble with sig figs and you want to explore a little bit more about what a sig fig is and some of the rules when I start adding and subtracting them, I suggest you do a keyword search for the Atlantic Pacific method. It's a tried and true method to let me know which numbers I keep and which ones I don't. And that will be all for today. I'll see you guys tomorrow in class.